All right, sample problem 4.18 says use oxidation numbers to decide whether the following are redox reactions. For each redox reaction, identify the oxidizing agent and the reducing agent. Okay, so let me first explain to you what a redox reaction is. That's where I have something on the left side of the arrow and on the right side of the arrow changing oxidation numbers. Okay. So for instance, that would mean like aluminum and aluminum, okay? If those two things had different oxidation numbers on both sides of this arrow, that would be a change in the oxidation number. This would qualify as a redox reaction. Now let's say I compared aluminum, the hydrogens, the sulfurs, the oxygens, and none of those oxidation numbers changed. That would not be a redox reaction. So our first step is to assign oxidation numbers. So that's what we're going to do first here. And I'm going to look at aluminum in APAR first because that's the first one that's listed. I've got to see, do I have a rule? Right here it says, for an atom in its elemental form, the oxidation number is 0. Aluminum solid, that's aluminum. In its elemental form, I'm going to put a 0 there. Okay? It has a 0 oxidation number. The next thing listed there is hydrogen. I have rules for hydrogens down here. +1 in combination with nonmetals, -1 in combination with metals. All right, so let's see here. I have +1 because sulfur and oxygen is nonmetals. Let's look at the hydrogen on the right side. Right, I've got hydrogen here. This is hydrogen gas. That's in its elemental form. That means it's going to have an oxidation number of 0. And I guess we should have done aluminum as well on this side. Here it's not in its elemental form, right? So I don't know what it's got to be. I'm going to have to use some rules to figure out what it is. So I'll get back to that in a minute. Let's look at sulfur next. I don't have a rule for sulfur. I do have a rule for oxygen. It says for oxygen it's -1 in peroxides, -2 in other compounds. So it's going to have to be -2 here, right? So let me put my -2 above my oxygen. And now I can figure out the oxidation number of sulfur in my H2SO4, my sulfuric acid. Because if this is +1 and I have 2 of them, let me write that down here. And I'm on A part. See A for H2SO4. I'll put my colon there. Okay, so for hydrogen, I've got 2 times +1. So that's going to equal 2, +2. For oxygen, I have 4 of those times -2. So that's -8. And then I got to add those two things together, right? So that's going to be -6. So for sulfur, I have to ask myself, -6 plus what equals 0? X has to equal +6. So let me put my +6 above my sulfur there. Okay, so now let's see what I got. Over here on the right side, I have SO4. It's in the same situation as over here, right? That's a polyatomic ion. So that means that, let me get my thing here, that oxygen's still going to have a -2, and that sulfur's still going to have a +6. Okay, but I don't know about that aluminum, so I got to check for aluminum. Let's see, I've got Al2. SO4, 3. All right, so if I have 12, so for oxygen, I've got 4 times 3, right? So I've got 12 of those times -2. That's equal to -24. Let's see, my sulfurs, I've got 3 of them. 3 times +6, that's equal to +18. And now let me get some more room here. I'm running out of room. Got to add those two things together. What's that equal to? -24 plus 18 equals -6. All right, so for aluminum, now remember, we have 2 of these. Okay, so I've got -6 plus 2 times what equals 0. X must have to equal +3. Notice I had to put a 2 there because I got 2 aluminums up here. Okay, got 2 aluminums there. So we got to do that. So now I can put my +3. I'm going to go back to red since I had that one in red over here. So +3. So immediately I know this is a redox reaction. And I'm going to go ahead and draw my tie lines right now. Let me zoom back in up here. And I'm going to use red here. Aluminum changed. Oxidation numbers. Hydrogen changed. Oxidation numbers. So that's how you draw tie lines. You just use curved arrows and you connect the things that changed. Now I have to identify which is the oxidizing agent and which is the reducing agent. Okay. So aluminum went from a 0 to a +3. Its oxidation number increased. Okay? It increased. Or it lost electrons. It went from a 0 to a +3. And remember, if something loses electrons, it has a positive thing associated with it. So from 0 to +3, that is a loss of electrons. And I'm going to tell you this little thing here. Leo goes GER. G-E-R. You can always remember that. Leo the lion says GER, right? Because lions like to growl. Leo part says that a loss of electrons is an oxidation. The GER part says that a gain in electrons is a reduction. Okay, so what happened here? We said this guy lost electrons. That's Leo, loss of electrons. This would be an oxidation. Okay, it's undergoing an oxidation. So let me write that there. Oxidation. This guy went from a +1 to a 0. He gained electrons, right? His oxidation number decreased. He gained electrons. That's the GER part. Gain of electrons would be a reduction. So I'm going to write that here. Reduction. And then the last part of this thing wants us to tell which one is the oxidizing agent and the reducing agent. And let me tell you a little trick here. If something undergoes an oxidation, it's a reducing agent. Aluminum was oxidized. It caused hydrogen to be reduced. So we call aluminum the reducing agent, okay? And I know that sounds a bit confusing, but that's just, maybe that me saying it like that just helps you figure it out. So I'm going to say aluminum. Since it underwent an oxidation, it is the reducing agent. All right, and what was it? Hydrogen? Yeah, so hydrogen, it underwent a reduction, so it is the oxidizing agent. And I'm going to leave B and C part for you to practice and do. So remember, assign oxidation numbers, see if they changed. If they did change, it is a redox reaction. Then remember Leo and GER. If it was a loss of electrons, it's an oxidation. Gain of electrons, it's a reduction. And then the very last step, if it underwent an oxidation, it is the reducing agent. If it underwent a reduction, it is the oxidizing agent.